Hello dear students, I welcome you all on the lecture series of mechanical system design and specifically on the unit of statistical consideration in design. Myself Professor M.R. Pardeshi, Assistant Professor in Kekewa Institute of Engineering Education and Research, Nasik. Our today's discussion or the learning objectives of this particular lecture is demonstrate the knowledge of probability and the standard statistical distribution, then to interpret the method of organizing and simplifying the data in consideration with the machine design components, then analyze the natural and design tolerance statistically, and to understand the concept of margin of safety and reliability in consultation with the different machine components. So let us start with the first slide. Before moving towards the next session, first of all we need to understand what is meant by statistics. So statistics is the origin of statistics. If you think about that, the statistics seems to have been derived from a Latin word that is a status, or the Latin word that is statista, or the German word you can say statistic, each of which means political state, or it is the method or it is the study to collecting, processing and analysis and interpret the data or the numerical data, or we can say the observation to interpret the things. Then to what is the meaning of statistics? The word statistics and statistical are all derived from the Latin words as we have discussed earlier, that is mean political state. Statistics is concerned with the scientific method, that is, as I told you, for collecting the data, processing the data, analysis of this particular data, interpret the data and how to represent it, that is to be specifically emerge in the statistics. So collecting the data, organizing the data, summarizing it, then representing an analysis of the data, as well the deriving valid conclusions and making the reasonable decisions on the basis of this particular analysis. Then what is the meaning of the word statistic? It is used to refer, it is related to the numerical fact such as the number of people living in the particular area, to study of way of collecting or analyzing and interpreting the fact, that is done in the statistics. So if you look at the definition by Croxton and Cowden, that is, it may be defined as the science of collection of the data and representation, analysis and interpretation of numerical data from the logical analysis. So first step is to collecting the data, then representation of the data, and then third one is the analysis of the data, and then by using this analysis we need to interpret the data for the further use. Then if you talk about the types of causes for variation, because we need to take the data from the, suppose we take the example from the factory, if we want to collecting the data from the factory, so there are broadly there are two causes, assignable causes and non-assignable causes. So assignable cause is nothing but it is the not occur at random, but it is due to always arrives as a surprise. So in a factory, as I told you the example, there are so many mans involved, machines are involved, materials are involved. So specifically assignable causes, it is occurring due to these three M, that is man, machine and material. So man is related to the inspection process, which is going to held by the operator. The manufacturing process, that is related to the machine on which that manufacturing process is to be done. Then third one is the material, that is called changes in the material frequently, that is the role of material. So assignable causes that can be precisely identified and eliminated. and the another cause is the non-assignable cause. It is the chance cause, or we can say random cause, or the common cause. It is a complex in nature or unknown parameter and which cannot be measured or traced. So non-assignable causes, it is unavoidable and cannot be identified. So basically these are the two causes which is related to the, as far as the design of any component while statistical data is to be considered. Then statistical analysis. So while doing statistical analysis, we need to see what are the different factors or the different definitions are involved. First is population. Population means it is the entire group of apparently identical components or elements under study or observation. And then sample. The sample is the small portion of the population selected for the study, for the further use or further decision. Then random variables. What is meant by random variables? It is the characteristics to be studied for further analysis. It is called random variable. So in the picture it is very clear that the population and sample. So sample is the small portion of the population and random variable is nothing but the characteristics it is to be studied for the critical analysis or for the further use. Then frequency distribution. What is meant by frequency distribution? Suppose if you take the example of number of newspaper sold during the last 10 years. So raw data, that is somewhere 22, 20, 18, 23, 20, 25 likewise. So frequency distribution is the representation of the raw data in the symmetric, systematic and useful way. So the paper sold in 18, 19, 20, 21 and these are the frequencies. So papers sold class interval is nothing but 15 to 19, 20 to 24 and 25 to 29. So class frequency we can call it as, or we can calculate, that is 2, 7 and 1. So that is 15 to 19, that is the lower and upper class limit, and 19 to 25, that is the 4 class width, that is the width of the class. Then if you talk about the frequency distribution methods, so various methods are involved. First is histogram. So in the histogram is nothing but the graphical representation of distribution of numerical data, and it is used to convey the data to the viewers in the pictorial form, that is called the histogram. So record of high temperature for 50 cities in degree Fahrenheit, and class frequency versus class boundaries is represented on x and y axis. So class boundaries and class frequencies are represented in the graphical form, that is called histogram. Moving towards frequency polygon. Now what is meant by frequency polygon? So class frequency versus class midpoints. So here midpoint we are calculating from the class boundaries. So here 99.5 plus 104.5 divided by 2, that is 102, and second example 104.5 plus 109.5 divided by 2, it is comes towards 107. So midpoint has to be calculated, and based on that the frequency polygon has to be drawn. So high record we can see that here 112 degree Fahrenheit is the temperature here for the 2018, or the 18 and 112 degree is the high record temperature. So this is called as the frequency polygon. It is from the class frequency versus class midpoint. Then if you talk about parameters of frequency distribution, so frequency distribution, there are two parameters. Based on that the frequency distribution based on, first is the central value or the central tendency, and second one is the dispersion. So how that parameter is varying towards the central value, and how that values disperse, or how that values are various, how that values are spread. So that these are the parameters of frequency distribution. Suppose if you take the example of, or the statistical analysis, mean, median and mode. So mode is nothing but the most common score. Median is nothing but the central score, and mean is nothing but the average of all the scores. Suppose if you take the example, for the results are 9, 2, 5, 3, 6, 9, 5, 6, 4, 2 and 6. So from this data, mode is 6. Why mode is 6? Because the most common score, here the 6 is repeated in 2 times. Here the median is the 5. Why it is 5? So median is the central score. So if you take the central score from this all the values, it is nearer to the 5, and mean is 5.18. so it is the average of all the scores. So it is very basic, you will get that. Then how to calculate the central value or the central tendency? It is the arithmetic mean that is indicated by mu. So mu is nothing but summation of all the observation divided by the number of observations, where xi is the number of observation and capital N is the number of observation. If the frequencies are given, then how to calculate the arithmetic mean? Summation of all the observation multiplied by the frequency, that is called summation of fi xi divided by summation of all the frequencies, means summation of fi, where f is the frequency of occurrence, or mu that can be calculated by summation of fi xi divided by number of observation if the number of observations are given, and mean and mode. Then parameters for defining the frequency distribution. So there are 3 parameters as we have discussed earlier to define a frequency distribution. First is central value. So there is always a central value for any kind of data where the frequency of observation is maximum, while the remaining observations are spread symmetrically about the central value like a bell shape. Here in the picture it is clearly seen that it is symmetrically dispersed. The observation or the population is under this particular curve, it is dispersed 50% towards the positive side, 50% towards the negative side. So here we can say that it is the maximum observation, here is the minimum observation, here is also the minimum observation. So measure of central tendency, that is by the 3 different types as we have discussed earlier also, that is by arithmetic mean, that is by median, and that is by mode. So all the mean, median, mode, it is measure of central tendency, but the meanings are different as we have discussed in earlier slide. So mean, what is meant by mean? The sum of all the measurements divided by the number of observation in the data set, that is called mean. So observed data, that is x1, x2, x3 up to the xn, and the 9 is the total number of observation. So mu that can be calculated summation of xi upon n. So here, and when the frequencies are given, so mu that can be calculated f1 x1 plus f2 x2 up to the fn xn divided by f1 plus f2 plus f3 up to fn. So summation of fi xi divided by capital N, that can be the formula to calculate the mean or the central tendency of a given data. Then if you talk about median, median is nothing but it is the middle value that separates the higher half and the lower half of the data set. Suppose in first question 11, 4, 9, 7, 10, 5 and 6. So ordering the data gives, so here is the 7 is the median. In from question number 2, that is the ordering the data gives 2 or 2.5 is the median. So again if there are 2 values comes around, so 2 plus 2.5 divided by 2, so exact value, exact median is the 2.5. Then mode, most frequent value in the data set, that is called mode. So here from the data set, if you look at the question 3, 2, 6, 3, 9, 5, 6, 2 and 6. So here the mode is 6. So the number of occurrence in the particular data set, the number of times 6 is coming out. So 3 times 6 is coming. So that's why the mode is 6. Then let's say taken another example for the height of kids at a shoulder. Suppose let us take are 600 mm, 470 mm, 170 mm, 430 mm and 300 mm. So mean, the variation and standard deviation, how to calculate. So mean is nothing but all the observation, summation of all the observation as we have discussed, divided by total number of observations. So here are 5 observations. So total of all the observation are 1970 divided by 5, it is 394. Then difference of each kid's height from the mean, that is comes from the variance. So if you taken the root or the square root or the square of the mean, then we can set the variance. So variance is nothing but, so it is about 21704 is the variance. Then standard deviation sigma, how to calculate. So square root of the variance, that is nothing but the standard deviation of the from the mean. So 147 is the square root of variance, is called the standard deviation. So 147 is the standard deviation, that is sigma. So variance is the square root of sigma, that is again summation of xi minus mu bracket square upon n minus 1, and the standard deviation that can be calculated, sigma is equals to under root of summation of xi minus mu bracket square upon n minus 1, or the another formula, that is under root summation of fi xi fi into xi minus mu bracket square upon n minus 1 if the frequencies are given, or under root of summation of fi xi square minus in bracket summation of fi xi bracket square upon n divided by n minus 1. So these all are the formulas to calculate the standard deviation, that is sigma. So standard deviation is nothing but the measure of how each value in the data set deviates from the mean. So mean is, we have seen that it is the central tendency, but how the data is dispersed, how the data is deviates from the mean, that can be identified from the standard deviation, and it is going to measure how the concentrated the data are at the around the mean and how it is going to concentrated. So the smaller standard deviation, more concentrated data is to be significant. So smaller standard deviation value, it is the meaning of the more concentrated data is there, means all the data is varied towards mean or dispersed towards mean. So smaller value, significance of smaller standard deviation is that, so more concentrated data is there. So mean is nothing but sum of all the measurement divided by number of observation in the data set, and the variance is variance and standard deviation is to be calculated. So these are the some of the formulas to calculate mean, variance and standard deviation. So again these are the some formulas when the frequencies are given, how to calculate mean, variance and standard deviation. Moving towards the one numerical, that is 100 test specimen of GCI are tested on universal testing machine to determine the ultimate tensile strength. Following are the results. So the class interval, the in megapascal, frequencies are given. So 261 and 280 frequencies are 281 and 300 megapascal frequencies are 12, 301 and 320 frequencies are 50, 321 and 340 frequencies are 32, 341 and 360 frequencies are 4. So convert this is in this form. So the we'll get the FIXI and FIXI square. So from this we'll calculate the mu. Mu is the summation of FIXI upon n. So summation of FIXI is the 31480 divided by n. N is given, that is 100 test specimen. So 100 divided by 100. So 314.8 megapascal is the mu from the problem. Then sigma is nothing but under root of summation of FIXI square minus summation of FIXI bracket square divided by n. total divided by n minus 1. So calculating this or putting the values, so 15.86 is the megapascal is the sigma, and variance is the 251.48 megapascal. So these are the methods to calculate mean, variance and standard deviation. If you look at the normal distribution curve, so data tends to be around a central value. So remaining observations are spread symmetrically about it. Suppose here these are the data. So from this we can easily plot this type of graph that is called normal distribution curve. So it is looks like a bell shape, and all the data below the curve that is called population, and as we have discussed in earlier slide, definition of population, definition of sample, and definition of variable that is to be critically analyzed for the further conclusion. So bell shaped curve is to be formed when the particular data is comes around the curve. So that is called normal distribution curves. So things close to normal distribution curve: heights of the people, size of the things produced by the machine, errors in the measurement, blood pressure, or the mark in a test. That all the data that can be handled by means of a normal distribution curve. So these are the some of the types of standard distribution or the standard deviations from the mean. Suppose if you look at the first graph, here we can say that 68% of the values are within the first standard deviation of the mean. Means what? Not 100% data is deviating from the mean, but 68% data is the deviated from the mean. So the one standard deviation of the mean. Then second, if you look at the second graph, in that case you will find that 95% of the values are within the two standard deviation of the mean. Means what? Here the plus 2 and the minus 2, plus 2 and minus 2 data has to be covered in the second graph. So 95% of the values are within the comes under the this particular graph. And third graph, if you look at the third graph, in that case you will find that 99.7% of the values are within the three standard deviation of the mean. So one standard deviation, two standard deviation, and three standard deviation of the mean. Here all the population is catch, or we can say that all the assignable causes is covered in the particular data, as we have discussed in the earlier slides. Assignable data or assignable cause and unassignable non-assignable causes. So if you look at the assignable causes, all the blue portion, it is called the data is produced due to the assignable causes, and about the rest of the or the outer portion of the standard deviation curve, that is indicating the non-assignable cause, that we cannot consider that or we cannot avoid that. So that is called chance cause or random cause or common cause. Then if you look at the types of normal distribution curve, there are two types: random normal distribution curve and standard normal distribution curve. So or we can say that is the natural distribution curve. So random or natural distribution curve, that is called, that is the random variable that is used, that is x. So x versus fx. So area under curve, that is n. So total n, capital N is the total area under the curve, that is all the observation, means capital N is nothing but all observation, that is called random normal distribution curve. And if you look at the standard normal distribution curve or the natural curve, that is the standard variable is z, and now z is calculating by xi minus mu. Mu is the mean divided by sigma, that is the sigma means standard deviation. So fz means previous case, that is fx. Here is the fz, standard variable is z, is equals to 1 upon under root of 2 pi into e raised to minus z square upon 2. So Z versus FZ. So area under this curve is N. In previous case, the area under the curve is N. N is the total number of observation. Here is the area under curve is 1. So 100% data has to be covered by means of this particular standard normal distribution curve. That is 1. So random normal distribution curve and standard normal distribution curve. If you compare that, so here x is nothing but mu plus z sigma. Here standard variable is z. Z is equals to x minus mu upon z. So here, so all the area under the curve, that is capital N. Here is the area under the curve, that is 1. So it is deviates from 0, that is plus 1 minus 1, you can see, or 0.5 plus 0.5 minus 0.5. So total is 1. So here z is 1, here is z is 2, here is z is 3. As we have discussed in earlier slide, standard deviation is 1, standard deviation is 2, standard deviation is 3. So here is the 1 sigma, 2 sigma and 3 sigma. Here is 68%, 95% and 99.7% is the population is to be covered under the curve. So x has to be calculated. X is equals to mu plus z sigma. So x is equals to mu plus sigma, or x that can be calculated. If it is 2 sigma, then mu plus 2 sigma. So x is equals to mu plus 3 sigma when the 3 sigma limit is to be calculated. So there are based on the 3 limits, 1 sigma limit, 2 sigma limit and 3 sigma limit, or we can say the popular word, the 6 sigma limit, plus 3 sigma and minus 3 sigma, the total is 6 sigma limit. If it is designer is going to prefer to use and give the flexibility to the operator while manufacturing the object or designing the object, so in that case, so 6 sigma is also the limit to minimize the rejection. So if you look at the normal and standard normal distribution curve, if each data value of the normal distributed random variables is x, is transformed into a z cross, the result will be the standard normal distribution. So normal distribution curve is converted into the standard normal distribution curve. So z is equals to x minus mu upon sigma is the formula to convert the normal distribution to the standard distribution curve. So here is the mu is 0. In normal distribution, mu is calculated and sigma is equals to 1. So total area under the curve or the dispersion under the curve, that is 1. So sigma is equals to 1 in case of standard normal distribution curve. So use of standard normal table to find the cumulative area under the standard normal curve is that how to find out. So here is the z on this particular y-axis, and on the x-axis z value of 1, 2, 3, 4, 5 up to 9 is given. Suppose the value of z is 1.25. So 1.2 is here and 5 is here. So the value of the z is 0.3944 is the value. Again I repeat, if the value of z, or if the area of is calculated 1.25, so how to calculate the value of z is a is 1.25, so 1.2 here, not 5 is here, so 1.2 up to 5, here is 4, if 5 is here, so 0.3944 is the value of a, and from this summation of area and we'll find the total area. So a1 plus a2 is the total area, and then we can significantly find out the rejection. So here the design and natural tolerance. So natural tolerance is nothing but plus minus 3 sigma. It is the limit within which all the allowable items fall, or we are giving the flexibility to the operator, flexibility to the machine, flexibility to the material. All the chance cause or the assignable cause comes under this particular category, plus minus 3 sigma. So it is called natural tolerance. So naturally that particular things has to be happen. And another is the design tolerance. So specification limits set by the designer from the consideration of machining of the two components. So here there are three conditions. So when the design tolerance is less than plus minus 3 sigma, it is the rejection is inevitable. When the design tolerance is equals to plus minus 3 sigma, there is no rejection. And third case is design tolerance is greater than plus minus 3 sigma, should be about rejection, or it should be about the rejection. So plus minus 4 sigma is there is no rejection. So all the population is covered. So here is, if you look at the diagram, so this is called the design tolerance and this is called the natural tolerance, isn't it? So from this we can easily find out the particular rejection rate from the batch of a population, or from the population or the sample which is going to study for the further use. So this is all about for the today's lecture or today's video. Thank you all for listening me. Thank you all.